how data centers actually work.
You could think of a data center as a building that experiences four main factors when operating: high heat load, high power and redundancy, network, and a field of operations that either need to be upgraded or high throughput.
How much energy is being consumed for a few LLM queries?
For every 20 to 50 questions you ask an AI chatbot like GPT, you consume about 6 times the amount of energy doing a Google search and about 17 ounces of fresh water.
Classification of different types of coolings
There's air and liquid. Maybe about 10 to 15 years ago, a high density rack might be 20 kilowatts. Today, Jensen Huang, NVIDIA at GTC, he announced 600 kilowatt racks.
What about the cost side of things when you compare air versus liquid?
For the operation of HVAC systems, air is more expensive to operate, but liquid is more expensive to install.
I recently read a news that Microsoft is pausing a lot of their operations for data centers, the new ones.
They still need to put OpenAI servers or their Azure's AI somewhere. Most likely what they will do is put it in Equinix's data center or Digital Realty's data center or whoever's data center. It is actually a smart move on their part that they don't want to hold the capex on their balance sheet.
In this episode of Constructing Tomorrow, we have Abhishek Sastry. Abhishek is a CEO and co-founder at Fluix AI. Fluix AI is an operating system for data centers, a software that helps data centers plan, run, and optimize themselves. In this episode, we talk about how data centers actually function, differences between air cooling and liquid cooling, how AI workloads are reshaping energy and cooling requirements infrastructure, environmental impacts and energy consumption trends, power distribution challenges with outdated grid infrastructure and interconnect issues, how data centers can be controlled autonomously with AI to reduce cooling costs, and much more. With that said, I bring you Abhi.
Hi Abhi, thanks for being here and welcome to the podcast.
Hey Sid, thanks for having me and excited.
Yeah, I'm super excited to learn everything there is about data centers today, and we can jump into specifically what Fluix does and some of the great things that you've been doing. But I wanted to spend some time and start from ground level. I haven't worked on a data center job, so I wanted to give the audience and myself some context on how data centers actually work.
So I think it's important to give a little bit of context. So I'm not a MEP engineer. I'm not a design engineer. I'm a thermal engineer that's operated data centers. So you could think of a data center as a building that experiences four main factors when operating: high heat load, high power and redundancy, network, and a field of operations that either need to be upgraded or high throughput. When thinking about a data center, a normal building, the way you would think about it is possibly occupancy or comfort when it comes to cooling. A data center is a little bit different. Where you're trying to cool down is servers. The problem with that is maybe about 10 years ago, servers had a pattern of the heat load. You knew that people woke up at 7 a.m. As time went on throughout the day, usage increased. By around 6 p.m., people would have gone back home, done other things. So heat load had a pattern. But today, with the way AI and inferencing and training and some of the processes we use, servers could iterate, hour by hour, maybe even minute by minute in some really. So that heat load is very unpredictable. And that goes into a little bit of the data center. So on the cooling perspective, because I know that's top of mind for every data center, I would think of it as you need cooling redundancy. So you might need, if it's air cooled, liquid cooled, immersion cooled, whatever primary cooling device that cools down that heat load, that needs to be up and running 24/7. These systems are built to run 24/7 continuously. Then you need to have redundant cooling and redundancy built in. So that's the first aspect. The second aspect is power. So power is something that's very top of mind for data centers. Obviously, they're very energy intensive. We know that a ChatGPT query or a Google query uses extreme amounts of energy. So you need to have the energy readily available. And the throughput of that energy needs to have redundancy built in. So there's a pattern that you're seeing here. High throughput, no matter what you do, redundancy. Then you have networking. Usually data centers are built around areas that have fiber, right? Back in the telco days, throughout the United States, people built in fiber. They overbuilt fiber in the early days. Then you had dark fiber, fiber that wasn't utilized. Now I don't think there's any dark fiber left, meaning all fiber, all the underground fiber has been utilized. But even in network, you have redundancy, different switch gear, different equipment. Then finally, operations. Data centers are mission critical environments. Even though people might leave at 6 p.m. after a workday, operations still go. You need to have people on standby at 2 a.m. Things could go down. You need to have redundant fail safes coming over. So imagine a building with everything turned up to level 10, if you will, when it comes to throughput, redundancy, operations. Now, data centers obviously have their level. They can be extremely simple or extremely sophisticated. And there are many different ways of thinking about it. But I hope that provides a little bit more context on if you're thinking about a data center at a high level.
Yeah, I think that breakdown was super helpful just to understand. And I have a few questions here. Uh, Obviously, there is a lot of data centers being constructed now, meaning more power requirement, more cooling requirement, higher cost. Everything is, as I said, going on a 10x level than a normal building, if you will. Do you have any statistics on how much energy is being consumed for, say, a few LLM queries?
So there are a couple of studies that come top of mind. There was a UC Riverside study that found that for every 20 to 50 questions you ask an AI chatbot like GPT, you consume about 6 times the amount of energy doing a Google search and about 17 ounces of fresh water. So data centers use evaporative cooling. So that's if I ask GPT 20 to 50 questions, it consumes about this much amount of water. This is 16 ounces, 17 ounces. International Energy Agency this past week put out a projection that by 2030, data centers will consume the total amount of energy that Japan utilizes, which was interesting. Japan being obviously a major powerhouse in automotive, nuclear, and semiconductor and industry. Um, Personally, I think that there needs to be when looking at the energy perspective, there's several problems, but focusing on the U.S. because I think I understand the U.S. market a little bit better than globally because we're obviously based in Santa Clara, California, but we travel all across the U.S. We go meet with ERCOT in Texas. We met with National Grid and near Buffalo. We met Tennessee Valley Authority, PG&E, Dominion, and we know a couple of players. And I'd like to go to the ground level. So obviously, you have the source, whether it's fossil, renewable, etc. You have a distributor, right? You could think of the utilities that I mentioned. You have interconnect. So how do they take it from the source, take it to the distributor, and how they distribute it to substations? And then on the substation level, you have a city, right? So a municipality. And then from the substation, you take it to the source. The problem is with data centers, they can pop up fairly quickly for the amount of energy they use. So I'll give you an example. Back in the day, if you're building an airport or a large facility that are going to use some energy, you have a plan, you have a build out, you know that you're going to prepare it. So you might commission a substation for municipality. The problem is a data center, although it takes quite a bit planning, takes quite a bit of time. We're seeing interesting come up where data centers, the usage got spurred on by the pandemic. Everyone went home, everyone went on their network. That wasn't unforeseen. So we didn't know the network was going to hit. People were going to use communication and information technologies like that before, the rapid pace. We knew that technologies like GPT really put LLMs on the mainframe, right? The mainstream. So people started using these chatbots, and now chatbots are using chatbots. So we knew that data centers use a lot of energy. It came at a faster pace than we thought, and they're being built in areas where people can hook them up fairly quickly. And now the substation and the interconnects and the distribution has been broken. There are places in the United States that has power. We can power this, but can we distribute it to the right place at the right time while also keeping track of all the other needs for power demand? So Texas, Tennessee, I'm sure other areas that don't come to mind because I just might not know, produces more power than they consume. So Texas exports power to other places. They have power, but I think it's a distribution interconnect problem. So I would look at maybe, just maybe, the energy issue can be solved with efficiencies, with interconnects, with knowledge, with prediction. I think, yes, the data centers consume a lot of energy, but I think it's a deeper problem that there might be opportunities to solve it by focusing on the distribution and the interconnect. But that's just one man's opinion. So.
Got it. Yeah, it's interesting like how our local energy providers kind of supply so much energy to these data centers, and I think that also clarifies like the reason that you gave. Some of the states actually produce more energy than they consume, which equates to why some of these data centers are specifically located in areas like Midwest. I think has a lot of data centers. I think Southeast is also starting to ramp up, and I think I saw that US has like 4 or 5 thousand data centers, which is the largest in the world. And to your point, like it uses more energy compared to like Japan, which I mean it just fits right now.
It's crazy, man. And that's such a good point you brought up, Sid, because the US has about 5,000 data centers. The next country that has the most data centers, I believe it might be Germany or the UK. They have 500. So the US has 10 times the second energy. If you combine all the data centers in the world, obviously there might be some data centers we don't know about. The US has about almost 50% of all data centers in the entire world. It's absolutely nuts on the density. So it's a good point on the distribution of where these sites are, right? So
Yeah. Let's talk about cooling. I know you mentioned a couple of ways in which you could cool down the sensors, because that's what it boils down to in terms of data centers. Um, Give me a classification of different types of coolings there are and how it differs in terms of how faster or slower it cools down the servers. And after that, maybe we can jump into the impact it has on the cost side of things.
sounds great. So think of at the highest level data center that produces heat. The servers are the heat source. You got to take it from the servers that are inside the data center. You got to move it outside, right? Whatever form you can do that, and without giving I guess a class in heat transfer, which I'm not. I shouldn't be doing, but what I could talk about, there's different ways of getting that heat out, right? There's air and liquid. So air, you put a AC unit, we call it a crack, computer room air conditioning unit, which is basically an AC unit that forces cold air into the data center. It usually goes underneath a floor. The servers are on a raised floor, so the cold air goes underneath. There's usually something called hot aisle or cold aisle containment, where the cold air goes underneath the floor. It comes up through perforated tiles, and then the cold air in a cold aisle area goes through the servers, gets heated up, and then the hot air doesn't go back in the floor; it goes through the roof, right? So there's it's very important if you do air cooled data centers. The one thing you have to remember is you have to separate hot air and cold air. And if you can separate hot air and cold air, you can create a fairly efficient data center. If the hot air and the cold air, let's say the cold air from the AC unit mixes with the hot air of the servers, and it's not taken outside, right? You have to move the heat from the servers outside. You can create inefficiencies because then you're cooling down air that's already cool and it's not getting exactly right. So that's where if you have people think, oh, but there's so many issues to this problem, right? Chips are getting hotter, so getting the heat is being produced faster than you can cool it down. If that's the case, like that's where AI data centers, many different classifications of data centers, But in an AI data center, you might have a chip or a GPU, a graphics processing unit that produces almost 600 watts of heat. In a regular data center, like
One
a web
chip?
hosting,
You're talking
one
about
chip might, yeah, one chip, right?
wow.
So actually, this is a good point you brought up, Sid. Maybe about 10 to 15 years ago, a high density rack, we look at the heat load from a rack in kilowatts, right?
Mm-hmm.
A high density rack might be 20 kilowatts.
Wow.
Today, Jensen Huang, NVIDIA at GTC, he announced 600 kilowatt racks.
Wow.
The first data center I worked in was 300 kilowatts total. So one rack, one cabinet, there could be thousands, uses more energy than the first data center I worked in. So it's exponential. Now, in that type of data center where the heat is being produced faster than traditional methods, you need different types of cooling, like liquid. Liquid cooling has many different subsets. Excuse me. I used to have a liquid cooling company. One common method is called, there's evaporative cooling in HVAC, right? And I can explain that. But just to go over a subset, in liquid cooling, you usually have direct to chip, where the cooling, think of a liquid loop, like a water line loop, where the water goes into the servers and it doesn't touch the electronics, but it touches a metal cold plate that attaches onto the server chip. If anyone's built a PC, you've attached a cooler onto the processor. It goes, takes the heat from the processor in that liquid loop and takes it to a radiator outside. Those types of situations are meant for chips that are very hot. And then some people might be similar or familiar with this. There's immersion cooling, which is you take a liquid, not this type of liquid, you take a non-conductive liquid, like mineral oil, or there's many different classifications, many different inventions, and you put the server and you submerge it in a tank of non-conductive fluid. The fluid doesn't conduct any electricity, it doesn't mess with the servers, and you're able to cool it down. But whatever method you do, whether it's air or liquid, you have to remove the heat out. And there's many different analyses that you can do, but those are the main types of a way these chips are being cooled.
Would you say liquid coolant is better than the air one because the liquid actually reaches the coil?
So yeah, the liquid reaches the chip, right? So it depends, right? And I used to be I still am a huge proponent of liquid, but for some data centers, liquid cooling just doesn't make sense.
Okay.
It
Why is
really
that so?
depends. Well, it depends on your heat load, right? There's many providers out there that if you have a regular 300 to 500 kilowatt total data center, your budget and your energy constraints are in place. Let's say you're not close to the equator. There's many factors. It just depends on what type of equipment you're cooling down. What is budget? What is feasible, right? Air cooling could get quite efficient, actually, if done the right way, and if cooling down chips that are not as hot, right? So it depends on the heat load, I would say.
Got it. What about the cost side of things when you compare air versus liquid?
So the cost, that's a difficult question to answer, because in certain scenarios you have to spend the cost for liquid, right? So it's a very difficult answer, because if you will, for the operation of HVAC systems, air is more expensive to operate, but liquid is more expensive to install, right? CapEx and OpEx. Because with liquid, I'm talking generally, obviously there's anomalies. With liquid cooling, you have to install the pipes, you have to install the radiators, you have to install the pumps, you have to you have to redesign the building for liquid, right? With air, the methods are known. Air cooling, for the last 40 years, ASHRAE has built in, different types of standards. There's different councils that there's known methods, right? So installing an air-cooled system is understood. It might be readily available, even though I'm sure we'll talk about supply chain. Everything's broken right now, but is readily available. So the capex for an air-cooled environment is understood, and you can possibly get the equipment and install it, and those methods are known. The problem with liquid cooling, whether you're doing direct to chip or immersion, those reference materials and those guidelines, ASHRAE just created a guideline for liquid cooling. They finally got a guideline where it's like, yeah, this is probably how you should do it. Those guidelines have finally gotten to MEP firms helped in creation of those guidelines, but now it got to the HVAC contractors, and the HVAC contractors have understood it. And the liquid cooling companies, instead of just creating one specific type of technology, they've created the whole tech stack, right? Pipes, manifolds, pumps, CDUs. And now you have so now you can finally buy a full suite of equipment, go follow a guideline, and hire an MEP firm to do it. But that 3 years ago, probably not. Right? So
is there also a correlation that liquid cooling is probably a better alternative considering higher heat loads compared to like air cooling? Because I recently read a news that Microsoft is pausing a lot of their operations for data centers, the new ones, because obviously the AI is developing at such a rapid scale, needing higher GPUs, again, consuming more power, more heat generation, requiring more cooling. I think it's like a domino effect. And to your point, capex versus opex, again, I think I personally think that it's probably because they need to redesign the entire data center again to accommodate the liquid coolant.
yeah, it could be right. But I have such hot takes on Microsoft. So yes, to your point, it could be right. Instead of them holding all of that construction material, all the equipment on their balance sheet, right? They're a publicly traded company. Maybe just take the servers and go put it in data centers that are already built, or have someone else hold all that capex on their balance sheet. That makes a lot of sense. But Microsoft pisses me off because that like 8 weeks ago they came out with a design waterless liquid cooled data center. It's basically a data center that uses liquid cooling that is waterless, meaning it doesn't have an evaporative property. They're not running a coolant line that goes to a radiator where there's a fan and evaporates the usage of water. That has been done for a long period of time. So, Oak Ridge National Laboratory, when they did the Supercomputer Summit, it was a water cooled system created by, I can't name the company, but it was created by a company that uses a waterless cooling solution, right? It's a closed loop. The water goes, it gets cooled down, it goes to the servers, gets heated up, and then goes to a radiator, but that radiator is not evaporative and gets passively cooled and come back.
Oh, so you can just recycle the thing?
Right. So a lot of people hear headlines that, hey, Microsoft is pulling back on their data center build. They still need to put OpenAI servers or their Azure's AI somewhere. Most likely what they will do is put it in Equinix's data center or Digital Realty's data center or whoever's data center. It is actually a smart move on their part that they don't want to hold the capex on their balance sheet. But it doesn't mean that AI, for their specific AI, is slowing down, right? I think it's rapidly increasing. We're just getting smarter in the way we're doing things. I think that's what that means. And Sid, you brought up a good point. It could also mean that they don't want to spend the capex, right? So
Interesting. So, where does Fluix fit into the puzzle of solving the cooling and energy costs?
yeah, so our company is called Fluix. We run data centers on autopilot. You could think of us like the Google Nest meets Waymo for the data center industry. To break that down, Google Nest, you can control the temperature, fan speed of your home. Imagine us doing that for a data center. Waymo, autonomous driving cars. We're autonomous facilities. We're all software. So the way we fit in is no matter your data center, air cooled, liquid cooled, immersion cooled, whatever the data center, we are building intelligence. So we're a software layer AI that takes in data. We find the most efficient way to run your data center. What we found working in the industry is most data centers we visited, They have HVAC systems running at 100% all the time. It's very wasteful. Most data centers, even when the servers are not being ramped up, not being utilized, cooling is still run, right? They have to meet SLAs and different requirements. What our AI system does is it takes in all the data, it finds the best way to run that equipment. It might send off suggestions, but in the autopilot setting and actually control the systems, it'll eliminate the waste. So take a crack unit, an AC unit that's just blowing cold air. It might, in that scenario, say, hey, this is not necessary. Instead of just blowing cold air, let's ramp the system down. And, instead of running that system at 80 to 100%, let's conserve that energy for when it's actually needed. And we found that that's one aspect. Another aspect is if we help a data center save energy, let's say a data center uses 50 megawatts, we reduce it to 45 megawatts on their peak. What we've done is alleviated 5 megawatts of energy. What do you think the data center will do with that? They will pack in more GPUs for that 5 megawatts. We've taken their 50 megawatts of energy and they were able to produce more compute for that 50 megawatts because we were able to reduce the wasted energy that went to cooling, if that makes sense.
And so obviously you're collecting so much data. Is there something that you have to install in the existing data center infrastructure for it to collect all this information?
Yeah, so at a high level, these data centers, the way they operate is they most of the time, because they're a data center, because of regulation, compliance, and just how these systems are, they're mission critical. They usually have all the equipment in place. But the problem is data centers in the beginning might be homogeneous, meaning servers, HVAC systems, sensors, gateways might be from the same company and might be set up where they're all communicating and working together. But as the data center grows or as the global supply chain gets changed, a data center might be multiple different systems trying to work and speak to each other. So in the data center I worked in, a lot of the HVAC systems were actually different brands. So they did not speak to each other. Things were upgraded all the time. Things were changing. So it was easier for the team to just set everything on auto and have those systems just be overcooled. But in today's day and age, because of the energy constraint, because of the demand, these systems need to work in unison. So they have to be connected and updated in real time. That could be, to do that manually, there's groups that can help you do that. But what if an AI system can collect that data in real time and make sure everything is running and speaking with each other? Usually AC systems, when they operate, they take in information and they control themselves. So that was another problem. These HVAC systems run independently. But with an AI system like us, if an AC unit is operating, it would know what the other AC unit is doing too. So there's something in the data center industry called crack fighting, where an AC unit will ramp up and this one will ramp down. And this one will ramp up and it'll do like this. But now they're working together, right? So this is different types of way where intelligence, AI systems, can understand the physical world and the complex domain and have systems intelligently work with each other, where before they would be run on hard-coded requirements like if-then statements, right? If this happens, do that, right? So that's where we think of physical AI and how our system could work. And we've installed it in a few data centers to date, and we've been seeing some great results. So we're really excited about the future.
I had a question. How does it compare with the BMS system? Because isn't that also kind of similar? Like you can track everything. Again, to your point, everything has to be on the same manufacturer or the same controls. But how? Just kind of curious.
BMS systems are incredibly necessary for what we do. The way we look at BMS systems, building management systems, building automation systems, there's also DCIMs, data center information management systems, is they're great at giving a single pane of glass when set up correctly, right? They'll tell you all the information that's there once it's set up. they're not the best at making decisions. They allow the facility manager to make decisions. But I'm going to give a hot take. So we operate on top of those systems, right? We operate on top of BMS and DCIM systems. Once we know what to do, there should be a system, like an AI system, that goes and does that change. So a BMS system might give you an alert. Zone 5, humidity has reached above 65 degrees humidity. A facility manager would take that data and be like, holy crap, zone 5, what happened? And they would go check it out. An AI system might say, oh, zone 5 from the BMS, zone 5 humidity went up. HVAC system is operating at normal. Blast fan speed, increase fan speed in that zone. And then send an alert to the facility manager over text, put out a log request, do a change management request. It's done everything more than just a static change that might have been done, right? And it's done it with a subset of equipment that might not be working or speaking with each other. Now, again, BMS systems, if set up correctly, will give you that alert, but it won't actually help you go make that change.
That makes sense. Yeah. So, isn't you mentioned about security compliance? So, when you're collecting all this information on top of, say, your BMS systems in a data center, what issues do you usually come across? Because obviously, it's mission critical jobs. They obviously don't want the data to be out there.
There's many different ways these types of technologies go about, right? There's cloud-based systems, hybrid-based systems, on-prem systems. Usually in a data center, these control systems are usually on premises. They don't like the data going outside or inside. I used to work for the DoD. I've worked for mission critical data centers. These systems need to have a level of on-premise deployment, right? But that's what makes these systems incredibly complex. It's very difficult to replicate what we've created because we've taken the extra step to go inside and create a very secure system that operates inside the data center. Now, to do so, there's pros and cons, right? But usually, if you're controlling an AC unit inside a data center, it's best that you don't put it in the cloud where another data center is in that data center, if that makes sense, right? These are mission critical environments that take special care. So they need a lot of human feedback. They need a lot of constraints that have to be drawn out. They need a lot of visibility so you know what the system is doing. It can't be a black box, right? So stuff like that.
So, who is actually a customer? Is it all the big tech companies? I'm assuming they would have their internal FM department who does all the internal stuff. But are you targeting them?
So we're targeting the customers that would have a hard time, that need help. Um, from our understanding, Microsoft, Google, AWS, Meta, amazing companies. They have a lot of resources, a lot of amazing, smart people that can come together, that can go solve problems internally. Our customers need to get upset up very quickly. They care about their customers, right? So they want to service their customers. They want to earn business, keep reliability. They don't have time to go run projects on things that could save them money and alleviate load, but they need to focus on their job, right? There are usually one or two facility people that run a 20,000 square foot data center with multiple systems. In that case, what they usually do is they buy off the shelf equipment and software, and they keep everything running on auto, and they quickly realize that there needs to be new improvements and they can't do it all by themselves. So we're focused on those types of customers. And if you look at the basis of AWS, Amazon, Meta, those companies, they might have about 400 data centers. I don't know the number actually, but they might be 400 data centers out of the 11,000. We're focused on the 9,000 or 10,000 rest, right? So that's how we look at it. Now, it doesn't mean we can't service AWS, Meta, or Google in the future. It just means that there's a big problem to solve right now that we're really motivated for.
Uh, some of these smaller size companies, they also lease out spaces in the big tech company data centers, right? So I'm kind of curious, how would that pan out in terms of services?
Yeah, so remember, it's actually might be the opposite because AWS has their data center and they're constrained, right? We just realized that Microsoft doesn't want to overbuild, right? So usually AWS, Microsoft might take their servers and go put it in a colo's data center. So a colo will actually have, let's say a colo has a very large hyperscaler customer. Like, I'm not saying this is the case, but an Equinix might have Amazon use up 80% of their data center in New Mexico, for example, right? None of what I said is actually real because I don't know what's there, but that could be an example.
Um, what about cost savings? I know we talked about energy reduction, cooling reductions, and how that impacts usage. But in terms of like money saved, do you have any case studies or pilots that you've done where you've seen that numbers?
Yeah, so we worked with a manufacturing company in Berkeley that had an IT environment. It used it as a test bed. Our AI system learned by taking in that data when to run the AC system efficiently. And basically, what happened was compared to the AC system running on auto, just overcooling the environment, our AI system learned that, hey, outside temperature is pretty cool, server utilization is not getting that hot, turn off the compressor and just blow in the cold air from outside, free cooling for a limited amount of time. And before temperatures inside the data center got too hot, start the refrigeration, the compressor cycle, and cool down that air. So it was dynamically changing this system. We were actually able to reduce energy costs by about 37% on that unit. So that was some of the early work that we've done. Now what we're doing is we've implemented across a couple of data centers. We're working with a big group in LATAM. We're working with some groups in Tennessee and in Florida. And what we're doing is we found that data centers in the Southeast, close to the equator, that have multiple environments, are seeing energy reductions by almost 20% on the HVAC side. That's with systems compared to running on auto all the time. We can get to even more savings, but it really depends on what type of system, what can the AI learn. Our goal is we found a subset of customers that we're working with where they believe in a system like this. We can quickly expand to another data centers and sites in their portfolio. And because of either they're close to the equator or their municipality has increased their energy rate and they're smaller data centers, so they couldn't lock in their rate for a long contract, or they have multiple fragmented systems that don't work with each other, it actually gives a great case study to try our system. So, and the third aspect of this is we have a lab. So as a startup, right, as an early stage company that has a lot to prove, we wanted to put these AI autopilots, if you will, with our own equipment, right? Put our own equipment at risk to showcase that it's safe, that it works. So in Santa Clara, if anyone's in Silicon Valley and maybe message me on LinkedIn or finds us, we could show you a lab. We host events here. We have our AI system working on a couple of HVAC systems. So those are some of the ways that we're showing that this very new concept of physical AI control systems can be done in a safe, reliable, and effective way. So those are a couple of things we've done.
Awesome. What's if I may ask, like, what's your vision for Fluix, like 5, 10 years down the line?
I think data center is a very difficult problem, but I think data centers can be run fully autonomously. Imagine a dark data center that's a lights out data center, a data center that doesn't require lights. The whole point of that is if you don't have any humans inside, you don't need to waste energy on lights. It's a very difficult problem. I'll tell you why. Right now, we're at this stage where we're optimizing HVAC system, right? We can change HVAC. But what if you want to commission a server? That's a big problem, right? You have to physically slot in that server, connect that server, put the equipment, the motherboard, the RAM, everything. But then you got to link that server to a load balancer or a duty manager or a scheduler. We believe all of that, after the hardware is put in, can be automated. Right now, there's humans physically dragging, putting in information. That can be auto-populated with a combination of Gen AI and physical AI, right? Then there's another aspect to this where, the load can be communicated to the grid, right? That there's a big disconnect where if you can use AI models, you can predict the load, you can let the grid know. And that's a huge problem. A lot of companies are working on that. But simple stuff like ATSs inside a data center. Think of it as a power distribution room where the power comes in from the utility that goes to that room, and then the power goes out to all the servers, all the UPS systems. Sometimes you can get an arc, or you have to physically turn off the machine. And it's unsafe for a human. A human has to put a full arc suit. They have the big hook you've probably seen. Instead of having a human or a robot turn off that lever, you can have an AI system cut the ATS from within, right? Simple stuff like that. So I think of full automation as there's more automation that comes in, that one day you can buy underutilized real estate, or you can operate underutilized real estate, get it cash flowing on a data center model, reduce OpEx because you can automate all of these different types of problem segments using AI agents. But it's a very difficult problem to solve. I'm not saying that we have all the answers, but I guess we're crazy enough to try. So
Yeah. Well, Abhi, this was so insightful personally for me. Like again, as I said, I didn't really come from a data center background, so I actually gained a lot of more information from this. If anyone has to reach out to you, what's the best way?
you can reach out to Fluix at fluix.ai if you want to learn more about our business. If you want to hit me up, you can go to LinkedIn. I'm on X now at SaaS Abhi, SAASABHI. So that's a couple of ways. And thanks for hearing me yap for the last 40 minutes.
No, this was awesome. Thanks, Abhi.
Thanks, Ed.